add a quarter here. I'm kind of worried about that one. Uh-oh. Did the stream reset? I didn't drop any frames. Huh. The stream preview started playing again for some reason. Okay, anyway. Yeah, I'm worried about this quarter pixel thing there. I guess we'll see what happens. What did I do wrong here? I have an extra parentheses. That's what I did wrong. Okay, I'm a little worried about this change. Might have messed up my pixel perfect dashed lines. Yep, I messed them up. Oh, the quarter is important because it's shifted. You see what happened here? They're shifted to the right. They need to be shifted back to the left, these horizontal lines. So that quarter was actually it was a quarter of a row, not a pixel. It's this 0.5 I need to keep. Is that the one I accidentally? Yep, that's the one I accidentally removed. Okay, so that needs to go back in here. So that's minus 0.5, right? Okay, good. Back to looking good. Look at that. Look at those nice pixel perfect dotted lines. That looks up. Actually, this one looks off. It's off by 1 pixel. Okay, so I need to add 1 to the starting position. I think. Yeah, we need to add exactly 1 pixel to here. So plus 1.0. Oh, that looks lovely. Look at that. Right where they cross each other, the horizontal and vertical lines, there's a nice like staggered pattern there. Okay, there it got off somehow. Oh, because it's the math rounded, like I guess the row height is not an exact integer or something. So it like happened to roll it happened to pick that vertical pixel position rather than the one above or one below. I think that's fine though. And there again it happened there. I'm going to accept that small difference. Yes, see on the bottom where it bends over to the blue, it also doesn't quite align right. That's fine. Doesn't have to be perfect. It just has to be close enough. So this blurriness, right? So that's the draw text. Let's do that one. Oh, also these ones up here, right? Wherever we do this weird floor thing, right? I'm thinking with this center X, it's always offset from that. So what if I calculate that once as a position and then add to it? Let me get back to that later. Where do I draw the text? Oh, here's another one I can do. What is this one? This is the vertical line. Okay, so here we just remove the round and adding 0.5. And here we remove the rounding, adding 0.5. Same thing here. Same thing here. Okay. Baby steps, one step at a time. Confirm, then move on. That looks okay to me. That didn't mess anything up. Yeah, right where the horizontal and vertical lines join, sometimes they're off by one. If anything, I want to add 1 pixel to the end of the vertical lines at the bottom. So that's here, right? I would add oh wait, I'm already adding 0.5? No, I want to add 1. That's probably why I did that. There was a bug there. Nope. Nope, that was wrong. Oh, because this is inside the multiplication. I need to add 1 after that. Yes. It's adding half a row. I didn't want to add another half of a row. Okay, how does that look? That looks good. I'm happy with that. Okay. Get back to the text that I was looking for. Selection rectangle. I think I'm okay if it's smeary. I don't remember why this is here. I don't remember why that's there. I think I'm going to delete it. Here we go. So here's the text. So this is pixel align, right? And then more text, right? Pixel align. Yeah, this severe indentation means that I really need to refactor the code. Extract functions and the like, make it nicer. Don't know if I'm gonna get to that tonight. Oh, that looks so much nicer. Look at that. Vertically, it's not smeared anymore. Horizontally, it's still smeared. That's weird. That did change. That did vertically unsmear it. Right? Maybe it didn't. Maybe I'm hallucinating. Maybe we remove this and see if it actually had an effect. I say yes. It's possible it had no effect. Yep, it was a hallucination. Well, actually, the bottoms of the brackets, maybe. It's really hard to tell. Well, what I'm doing is I'm doing pixel alignment so that it doesn't need anti-aliasing. I mean, it's more the aliasing is prominent when we zoom in, right? But if you look at it unzoomed, you don't really see it. I think it's fine. I think I'm just gonna say this is good enough. Magnus, you have done your job splendidly. We can dismiss you now. I won't use your magnifying glass. Okay, yeah. I want to be able to click. Yeah, clicking on a byte should find the innermost data component. So I think we can follow the rule that if you click somewhere and there's a sequence that you can if you go past it like that, then you can stop looking. Although maybe I guess it doesn't really matter. We wouldn't descend into any of these if it's out if we click outside of this we won't descend into it. So like if well data is another the vector ones we have to look at all of them, right? Or do I? Actually, we know we can prove that if like you clicked above the very first one, then we can stop looking and we can just escape back out. The tricky one was when we were looking at this global color table, right? And like we're looking at the red components. So if we like click somewhere in here, if like you click somewhere between these two bytes, once you get to 15, you can stop looking. But let's say you clicked on this 9. It's like, okay, you're almost there, and oh, you passed it. So it's neither 14 nor 15. So what do? I think you stop looking once you go past it, and then you go back up the tree and back down into green, and then you'd find it there. Yeah, and I think once you find it, you only descend down that and you ignore all the other siblings. Okay, I'm just preparing the algorithm in my mind. Although, you know, I already wrote this once. What if I just look at the C# version of this? I have to kind of remember where that is. On render. Actually, I don't even remember if it was in datatree.cs. It might not have been here. Where would it have been? Maybe in the main code behind? Network connection script. It's nowhere here. I don't know where to look exactly. Command. No, that's just that's something else. Yeah, it's not any. I'm not sure where it is. It would be here if anywhere. Because this is the window that would host the hex editor. Okay, it goes to the script host. Okay. Script host is in the model. Script host. Oh, was that in script host? Yes, this one. What? Just goes back to Lua? Then where would it be then? What is the reason to rewrite in Rust? Just for fun. The whole stream is about doing stuff in Rust for fun. Also because I wanted to do some more development on it, and I didn't want to do it in C# or C++ anymore. Because it's really old and it's hard to build for me. This is just a Lua connection, right? So then would it be in the C# wrapper? I forget how this is built. Anyway, I can't find it, so we're just gonna write it from scratch. Yeah. In the app. When we handle a message, and the message is that you clicked on a byte. Okay, I guess I don't have a message for that, but there should be, right? Select byte or something. The cat needs to go out. Wanna go out, kitty? Meow. Select byte. So now we can add the code to handle it. Offset. We'll get back to that one. Okay, so it comes from the hex editor. And it will come from draw, right? It'll be if you clicked. Here. Byte selected. Here. Right, so we just have a debug. So instead we want to do send a message. And it's select byte. Offset. If anything, we want that debug message over on the other side. Okay. Where am I going? I'm going back to the app. Here. To where we're not using the offset, right? This to do. To paste that there, and let's turn that into a print line and make sure it works. Okay. You clicked off different offsets. Great. It's working. So we're going to keep that in there, but it's a debug now. Okay, so then we want to go through our data tree, right? The data. Where do we store the data? Okay, a little confused. Oh, the info overlay has it? Did I put it in here? I did. Okay, so then we're feeding it back to the info overlay. Select data. Select data. Select data. Select data from offset. Select data from offset, mute, self, offset, view size. Okay. So we're going to go find, right? Hold on. Do I actually store the original shared component? No, we don't. So I need to store that. So I guess we'll call it data root. What's data tree? Oh, that's the UI. That's the view. Okay, we want the root. That's one of these guys. There's another problem, right? In that I don't have a reverse map from data back to row token. I need that though. The alternative is I can ask the data tree to enumerate its rows. Maybe that's a better idea. I caught a cat. I caught a cat. Hello, cat. I have caught you. Caught you messing behind my desk. She's going back there where she's not allowed. So if we can ask the data tree to enumerate, because it already has this root, and then from the rows, where is it? From a row, it has the children in a vector, so we can have it. Oh, it also has the visitor, doesn't it? Didn't I build in a visitor to this? Yes, I have visit, but it's only visit visible rows. I guess we can have it visit all rows. That's what we want, right? Okay. Did I think ahead? Do I have it? Does it remember? Does a row remember its parent? Row, where are you? Row. Yes. Okay, great. So once we find a row, we can navigate all the way up and just expand at every level. Okay, then I think I know what I want to do. So we don't want to put the root there. We're just going to go to the data tree and say visit visit what? Visit rows, right? Why is this called root rows? Root row. Oh, because yeah, so it should be visit root rows. And then what are we going to get from that? Row token, row. I think we should just get the row tokens, right? And with any of those, we could just do a nested call. Hey there, King. I'm doing fine. How are you? Did you just get here? I can show you what I have gotten so far done today. So now you can click on any of these and it shows it, and then it'll also scroll, so I can scroll to like any block I want. We also have it, how do I say this? Like on data block 0, see how like it it doesn't have 3 rows for anymore here. It just put them all in the same row. So now we can look at a glance that, oh, that's a application extension. I also have like a little number in here showing how many blocks there are total. And so you can click on any field here and it shows you which bytes it covers. Now I'm trying to do the opposite direction where you click on a byte and it brings you to where it is in the structure. Yeah, it is pretty. You can also do that. Okay. See, what we're doing here is when we ask the info overlay to select the data from an offset, we're going to go to the data tree and visit all the rows and basically find the row that contains, like, is the one that contains the byte. And then we drill into it and find, okay, which one of its children also contains the byte. And we keep going until we get down to the leaf node. So I'm just looking at what the function object should provide. It should really just be the row token, right? What's this use size thing that it's giving? Oh, that's a level. Do I care about that? I don't think I do. So this would be token. Actually, what if we just do visit child rows? Or visit rows and we pass in the, an existing token and then it just enumerates the tokens of the child of the rows under that. Then we would just look it up, right? Because we have a hash map from row token to component. We can find it. So let data equal self dot data dot get token. Visit rows doesn't exist. Let's make it exist. Can you add a random color to the bytes for grouping, or maybe just underline to show the groups? What I was thinking about that was having different levels of highlighting. So the outermost would be one color, and then the next level in would be maybe a slightly lighter color, and then the third level will be even lighter, and so it would be kind of look like a cascade of highlights. Oh, you're reminding me. Color. I also want to use color to indicate if there's an error in the parsing by using red instead of gray text, and I keep forgetting to do that. I think I put it on my to-do list, so it's okay if I forget. Data tree, right? Yeah, let's just put it here. Pub function visit rows mute. So this needs to be an F where it's fn mute. And let's also return an R. And we're getting what is it again? It's a row token. Self actually that doesn't need mutable access to self. And then it's like parent optional row token. There. And this needs to return an R. You're blown away by it? Have you seen the new update note for your VS Code? No. What's update note? The what's new? Release notes? So I'm on the October version. I don't know what version you're on. 184. I'm on 184 dot. Oh, there's another one. So what are we blown away by? What's new that's really cool? I don't want to have to look through this now. Maybe you can tell me what you're blown away by. Features? Is features a feature or is it a specific feature? Okay, visit. What's wrong with this? Expected an argument. I gave it an argument, didn't I? Two arguments were given. Oh, it doesn't like this? Unexpected argument of type. One argument found two. Oh, I need to have the F. Okay. Borrow. Okay, cool. I suppose we should just unwrap this or expect. Data for row should be found. Should be found. There we go. So then, okay, you get a reference to it. And essentially we're going to return, like, I think we should just return whether it's the offset is in it. So maybe visitor pattern isn't the best here because I forget how I actually use that for Firefox crash. Don't know if anything will be interesting to use massive changes for you because you have used VS Code 5 years ago. You've remote. Well, yeah, for me it's incremental changes. So I like VS Code. I suppose if I hadn't used it for 5 years, I would be blown away by how many things have been added to it since. Yeah. Okay, how does this work? It gets a result from the visitor, right? Oh, it's compounding on itself. It's passing it in and then passing it back out. So it's building a result. So how do I use this for the new selection, right? Okay, so then I know what to do. I do have to change this to pass in the R. So we pass it in and we get it back out. And that means we have to pass in an initial. This doesn't do it. So how does this work? Oh, it's an option. It's always an option. Okay. So then it's always starts out as none, I guess. Yes. Okay. This is not the best design, but that's fine. It's option R, option R. Options all the way around. This is what happens when you design stuff late at night. You end up with stuff that doesn't feel right. Because we're going to have options all around here. I kind of think that it would be better to just make an iterator type. What if I just do that? We'll just do rows, and there's no function. It's just self, and we give you rows. Oh, this parent has to be passed in. It's extending the borrow self, but that's okay because it's an immutable borrow, right? So it'll be rows. Self and parent. So we just have to make this type. Let's put it afterwards. Data tree, right? And then parent, right? And then we'll need to have an index. Okay. So implementation of this is public function new. It should take a data tree. And a parent. Data tree parent index is 0. Lifetime. Okay, so I have to annotate the lifetimes. Is this how you do it? Obviously not. Data tree. This has to be declared then, right? Okay, that's what I needed to do. Okay, so then implement iterator for this, and here we can trying to get away with not giving a name for the lifetime. Missing members. Type item equals row token. Okay, so mutable self, option self item. What we do is we say we have to find it first. Let row equals self dot data tree dot rows dot get self dot row parent. It's if let some parent equals self parent, then it can do parent here. And if it's not, I have to go to root, right? Yes. Yep. Okay. So else let, well, this is, what's, it's a row, right? And a row has, what I really care about are the children, right? So either way, we're gonna get some vector of row tokens, and we're gonna borrow it. So this way, so it would be this dot expect. Well, hold on. If it's nothing, then it's a bad token. So we should do let some row equal that, else return none. Then it should be row dot children dot get self dot index. Actually, wouldn't it just be row dot children? And then we're basically getting the children here, or tokens. Yeah, tokens equals this, and then it's just row children, and then so get a borrowed vector usize, so it's going to be tokens dot get self dot index. That's the result, right? Let next equal that, and then we have to advance if next is some. Self dot index plus equal 1 next. This needs to do like a cloned, I guess. Cloned to have the correct type. Okay, so then or copied should work too. Okay, so this to do. Then it's self dot root or self dot data tree dot root. There we go. Okay, so now we have an iterator of rows if you give it a row token. So then what's this error up here? Private rows in public interface. Oh yeah. This needs to be public. And back here for another error. So right now it's not, so this should be a lot easier then. So it should be or it should be like if let some oh, this also needs to be recursive, doesn't it? We'll do the non-recursive part. So the non-recursive part is like if you actually find some data, well, row, if you find some row, some token equal, yeah, this is going to be an internal function. Find data containing offset. Offset size, or find child containing offset, and that means I need to have a parent, which is a data tree row token. And this is returning an option data tree row token. Okay. To do, we're not finished with this yet. Doing this one first. If we get one, so, this should be option, by the way. So the beginning one would be none offset. So if we find one, then we want to actually like get it. So well, no, we don't have to get it. We just tell the data tree to select it. So select row token. So I need to select row for here. So we have a bunch of functions like add row, expand row, collapse row, all that. Now we'll have a select row. Token, row, token, to do. So which one, what do I want to do first? Well, I need to make this compile. So to find a child containing an offset, we would say, it would be self.datatree.rows parent dot bind, and the predicate we get is a row token, and with that token, so given a token, what we're going to do with that token is return it. So then it's all in here. So yeah, I need to do this in there, or delete this. Okay, so I get the token out, and then I say if let, well, this should just say let some origin equal data dot borrow dot, oh well, we should let data equals data. Can I do a borrow up here first? No, I don't want to, we need to keep the temporary. So borrow first, and then data dot origin, else it's none or false. Find once a Boolean, right? Find once a Boolean. Yes. False. Return false. So it can't be in something that has no origin. Actually, that's not true. It might be in one of its children. So if it doesn't have an origin, what do? I guess we say we recurse. So if it has an origin, then we can either go into it or not. If it doesn't have an origin, then we need to go into it. So this should be a decision of let enter equal if let, so this would be true, else it would be no, this, it would be whether offset is greater than origin.offset and offset is less than or equal, or is less than origin.offset plus origin.limit. Else it's true. Rust style question: in the select data from offset function, does it make sense to explicitly return a null value in case there isn't any data found? It doesn't actually return anything. So what it does is it actually it'll select it if it finds it. If it doesn't find it, it just does nothing. Yeah. So it's like an imperative. It's like, please select the data for given this offset. It says, okay, find the row that contains it. If we find one, then select it. But if we don't find it, it's like, actually, you know what I should do is, if we don't find it, we should deselect all rows. But basically, if we had another row selected and you click a byte and it can't find it, it would just do nothing, which maybe we don't want it to do. What would we expect? So let's say you have something selected like, I don't know, you selected the width, right? Let's say I clicked on something and we couldn't find it because maybe there was a parsing error before we reached it. Should it unselect this? You know what's weird is it's removing the selection. I think it's because I have this code, the code in there that does that, the drag. I think it actually should. So let me give you a point for leading me to that. Oh, hello, Kitty. You want to say hi to the chat? He's like, no, I just wanted to mess with you. You now have a useless internet point. Congratulations. Yeah, so let's put that in here. So it should be like else. Actually, if select row took an option, then we could then say just select row whatever it returns, right? There we go. Make this take an option. Perfect. Thank you, Haste Blast. That was a great idea you and I came up with collectively. Okay, so I actually if we actually hit a row and the origin is way before the begin, if this is not true, then we want to actually exit way early. So you just OCD of a function with a single conditional. Yeah, it was sort of a code smell anyway, right? It's like, what's the else gonna, what do you do for else, right? No, and it's not even a Rust thing. I think you just identified that like we had a code path that did nothing. It's like, shouldn't there be an else, right? Now it's always doing something if nothing more than just saying we're selecting nothing, right? Because this might find nothing, but we're going to still we should still have like the data tree should decide what select row nothing does. Yeah, exactly. I don't think I want to structure it this way. I want to say by default, enter is going to be true. I also want to, is there like a iterator that'll stop early? If not, then maybe I do a for each. And I just do a break. I don't remember. Is there a short circuiting find? What I'm trying to achieve is that, like, if this is not true, not only do I not want to descend into his children, I actually want to break out of this find completely. Why don't you use ChatGPT? I've been doing that, yeah. Actually, what I've been using is find. Someone told me about this. Find is like a programmer version of ChatGPT. So we can ask it, is there a way to end an iteration early when using an iterator in Rust? Oh, mighty AI, deep thought. Give me your answer. Oh, there we go. Take while. But how do I use that? This will only yield the okay, that's okay. Yeah, so maybe that's what I want to do. I want to take while we don't see one where the origin is beyond the point that we're looking for. Okay, my almighty AI, you have helped me tremendously. So then, yeah, so then this, yeah, I don't even need a thing there. We will do a find, but I want to do a take while token. And we'll just have a different predicate here. We'll still do this, right? We're going to look things up twice. That's the only problem. I think it's fine, though. So we'll let the origin, let some origin equals data origin, else return true if offset is less than origin offset. So like, well, better phrase be the offset of this one is beyond the origin, the offset we picked. It's difficult to think of because there are two offsets and they're different, but yeah, then this is return false. Actually, then isn't it just return that this is less than or equal to and call it a day? So we take while we're still in candidates that we might find, and then we're going to find it's if there's some, well, I guess it's again, I'll let it be something else. No, it's if let. If we find it and the offset's greater than the origin offset, so if it's within that, then we found a candidate. So then I want to eliminate the alternative, right? Which is that it's either less than if it's before the beginning or, well, that's already, we already know that's false because we would have stopped looking. So really have we found, is it past the beginning? No, no. Oh, this is hard to think of. If it's after the end. Yeah, if offset is beyond the end, then we can return. We haven't found it yet. Okay, but if we get past this point, then we want to descend into it. So how do I say this? I think, well, I think then I don't need to have an else here. Borrow. Unneeded return. That is true. That's already borrowed. Okay. So the to do here is we see if if it has any children, then we go in and find again recursively. Yes, it would be like if let some child descendant equal self.find child offset. So that parent is some token and offset. Else, if we can't find any child, then it's ourself. So then it becomes, doesn't it become self.find child containing offset or token? Or is it or some token? Let me guess it's token. I'm always bad at these. Let's see if I got it right this time. I think it might be or some token. Actually, that'll work, right? No, we're wrong. Expected bool found. Oh, shoot. Find. Find is not the right one then. Find map, right? Find map. Is find map the right one here? This is none then? Applies the function to the elements of the iterator, returns the first non-null result. Yeah, that's correct. Okay. First non-null result. Yes. I think this will find it. I think I'm done. Did I do all the to-dos? No, I have one to do. Okay. Select row. Okay, this one's easy, right? So we just have to find it. So, and then we have to expand. Does expand row like go up the chain? It does not. Okay, so it's if let some token equals token. Else Actually, there's no else. It's just self.selected row equals token. If we're actually selecting one, then I want to do is I want to expand all of its parents. So while token is sum, so it really should be if token is sum, then it's while token is sum, isn't it? Yeah. While token is sum. Actually, it's the other way around. It's while let sum token equal token. And this goes here. We want to get its parent, and then if the parent is something, so let parent equal, well, we need to get the row first. Let row equal self dot rows dot get token dot expect should find a row. If right, it's self dot expand. Right, if let sum parent equal row dot parent. Expand the parent. And then token equals, so this is this has to be mutable. Token equals parent. Is that because it was moved out? Row parent. Child. Why didn't it like that? Wanted an option. Oh, well, what was wrong with that then? Mutable. I see. Well, I can move this around then. There we go. What does sum do? It goes back to what are the possible variants of an option. So it's kind of like a pointer can either be null or it could be non-null, right? If you're familiar with pointers, if a pointer is null, then it doesn't point to anything. If it's non-null, then it points to something, and you can follow the pointer to get to that value. Option is kind of like that. So option means the value either has nothing in it or it has some value of the inner type. And then the if let, what it does is if the thing on the right is an option, then if let does two things. It goes into the if the thing on the right is something, and it also like gives you access to that thing inside of it. Yeah. So let me see if I got this right. So if you tell it to select a row, it remembers the selected row, and then what it's doing is it's walking up the ancestor chain. While that token is a child of something, we get the row, that child row, and Then we walk up to its parent. If there is a parent, then I guess I could use the word token here. If the row parent is a token, then we expand that row. And then we go all the way up to the top. Okay, well, here we go. Let's give it a shot. Then I think I need to call it a night. Because I gotta get up at 6 a.m. tomorrow. If actually I can get up at 7, but I have to get out of here by 7:30. Hey, look, it worked. It didn't go select that byte though, and it also didn't get the correct thing. Oh, you know what? It's doing a by bit offset, and I have to multiply by 8, don't I? Yeah. So where was that again? Right, this offset is in bytes. So I can convert it to bits if I do it here, right? Select data from... Yeah, this is just multiply it by, divided by 8. Or multiply by 8. Yep. Okay. Gosh, I hope this works. I also need to like, yeah, it has to go and select it again. Oh, it didn't descend. Shoot. It should. Oh, wait. Clicking and dragging turns off the selection, right? I think I should disable that. I think that's interfering. So go to hex editor. lib.rs in hex editor. Let's find who calls remove highlight. Find no references. Select bitstream region. Yeah, it's here, right? Yeah, we don't want this. We don't want it to do this. Let me just have it. I think eventually we want this to go up to the app and let the app decide what to do. But right now, we'll just turn it off. Okay, so I click. Okay, so then when we select it, we need to do the same thing as if the row was selected there, which is, what does the app do? Watching me navigate the editor shows you a way inefficient using my editor. I'm always keeping all that stuff in my head. I can't keep things in my head. So I have to constantly shift around. I'm not very good at keeping things in my head these days. Handle message, select row, select data component, right? Actually, so select data from offset it should call itself on that, right? Yeah. So, hold on, I'm gonna do that. Or maybe I don't do it at this level. Maybe what I get here is maybe this returns me something. Yeah, what if it returns me the same thing? We get a row back out. No, I think I want a data component. Yes. So I want an option ingestion shared data component. Yes. So then this will give me the row. We'll select that row, and then we'll take the row and we'll map it to self.data.get row. Option. This should expect, right? Data for row should be found. Another way I could do it is have it return the row token and the data because it has access to it. But anyway, I need to clone it then. Cloned. There we go. So then this actually returns me a data optionally. And then I say if let some data. Wait, no. Does this take an optional region? Yeah. So then I want to do this again, right? So shouldn't this just be like, we refactor this and then we call it here too? So hold on. Because this also gives me an option. Yeah. So, okay. Let's refactor this out. Refactor, please, into a function. And we're going to call it on data selected. And then we'll just say on data selected data. Or on data selected this. All right. Multiple borrow, right? So we got to pull it out. Let data equal that on selected data. Okay. I hope this works. So now whether we click a actual row and it tells us we selected a data like this, or if I click a byte here, yeah, see? Now we can either click here or we can click here. Gives us the same thing. Okay, it's not working on all the bytes though. So my algorithm has some holes in it. Sometimes it's picking the overall red, which doesn't make sense. Oh, I think what it's saying is it thinks it's somewhere in there, but it shouldn't. It should move on. What it should do is it should move on to green. Okay, I think I know what the bug is then. Yeah, look at that. It's pretty cool. Can I just map to reduce the duplication and find... let's see. Find child containing offset. Where was that again? That was in the data. So lost. So lost. Data tree, right? No. Info overlay. See, I can't keep it in my head. I have to take what you wrote and then find it again. Can you use a map to reduce the duplication? What's the duplication here? Oh, it's the take while. See, I didn't know how to reuse what we got from the take while. But you're saying maybe I can do the map first? That's not a bad idea. So the duplication of effort is the get and the borrow and getting the origin out, right? I can't have the origin escape because it's within a ref cell. There's special rules about this. This type ref cell. When you borrow it, you get an RAII adapter for a reference to the thing on the inside, and it's a temporary object, right? So if I were to take the result of this borrow and leak it out, it would be a lifetime issue, lifetime conflict. It'll basically tell me that it can't move it out because it's a temporary, or dropped. It'll be dropped before it's used or something like that. But I could, what can I do here? I could clone the reference. So am I only using the token to get the data? Okay, well, I do need the token later, but I can map the token. I can map the token to a token with data. That's what I can do. So we'll get a token with data here. So do, we still have to do the borrow inside of the take while on the find map, but at least I can do the expect out here, right? So I can do a data and token. So then I don't need to do that, and I don't need to do this part. As long as I repeat this. Oh, I don't want those double references. Shoot. So yeah, I need a clone here. How did that stay as a reference? Is that a reference? Or a borrow, I mean. How is that a borrow? How is that a reference or a borrow or whatever you want to call it? I want to have this backwards also. Maybe that's the problem. There we go. And this one's not using the token. There we go. Haste Blast, you have scored another point. But don't be hasty. Reduce. So hold on. The query can be deduped. Yes. So we deduped the query. You have to do the borrow. Not sure if it's better though. I like the fact that we only had to do the expect once. And also we avoid doing a double get on a hash map. Even though hash map should be fast, like why look it up twice, right? The cost is that we have to increment a reference counter so that it can the borrow can escape. Actually, maybe we don't even need to clone that one. Can I just use a borrowed? Yeah, okay, that's the answer. Don't need to clone it. So now it's a borrowed reference. It's actually a double reference. So I can actually, can I do that? No, I can't because that would be moving it out, right? So data is now a double reference because of how iterators work, but that's okay because it gets auto derefed here. See, is that ref type? So if I did the borrow here, just to show you that, I think it would say, oh wait, hold on. The borrow can escape. That's neat. Rust is good enough to be able to like extend its lifetime throughout the iterate. That's right, because they're all wrapped within like iterators within iterators, right? Like the type that we get out of find map is actually like a really complicated some implementation of iterator, right? But the actual type is pretty complicated. Cool. Then we only need to do borrow once, and now yeah, I like it. Of course, this is going to crash now, right? Nope, it still works. I have to fix this problem where it stops early and it says it's somewhere in red, but I couldn't find it. Basically, it's what it's saying, right? I think I know where to look for that. So it's when we get into here, right? And we say this. I think we don't want to say that if we have no origin. Right, so it should be like or else, or it should actually be origin. If some origin, then some token. So origin map to token. Data.origin map. Token. Although that's pretty indecipherable. What it's basically saying is if there's an origin for that data, then map it to the to the token. Otherwise, don't go into it. Or not don't go into it, but don't select it. Okay, so let's see if this works. Okay, cool. It went past red and found the green. Oh, we're not doing a scroll to. I need to do a scroll to. So just like I had it for the hex editor, I need to scroll to for the data data tree. Hex editor, right? There's like a scroll to. So I need this. Yep. So same thing, we need a scroll to. But not two things, but only one thing. Data tree. Scroll to row token. None. Okay, and then we set scroll to when we do select row. So if let some row equals self.selected row, actually, why don't I just say self.scroll to equals self.selected row. Easy. Anonymously 001. Hi, what is this project called? What's the purpose of it? I'm glad you asked. So it's called DataDisintegrator. And this is what its GUI looks like. It is using a custom language. We're describing a data format and then giving it to a tool that uses that format to figure out the meaning of every byte of a binary file that you give it. So if I describe a GIF file as starting with a header, ending with a trailer, and having data blocks inside, then drop an actual GIF file in here, then it says, oh, well, there's the header. There's the trailer at the bottom. There's the logical screen. Here's the width. Here's the size of the global color table. Here's the global color table itself. So it basically is a programmable decoder. You tell it the format, you drop in a data file, and it decodes it. Yeah, it's like a smart hex editor. Yes. It's programmable in that we can describe the format using this language I came up with. It's sort of like a mix between structure, definition, and function, because you can think of the whole file as a structure, and it has like fields that are substructures, like header, but it also has things like loops, and it has conditionals. And then there's the funny thing where that intersects is where you have a field inside a loop, it becomes a vector. So there's not just one data block, but there's a data block for every loop. So that's why data here has 61 elements in it. Every time it hit the big top of that loop, it parsed another data block. Does it convert image to hex code? It gets us down to the LZW compressed blocks. So these are the sizes of the blocks, and it's actually skipping over the content, which is all of the bytes between these two is one LZW compressed data block. So it's getting down to the blocks, but not going into them yet, because that's where I stopped in the format description. It's a little bit complicated when the blocks are not adjacent to each other. So what I was thinking is, if I were to dig deeper into this file format, I would do a 2-pass decoder. 1 pass to find all these blocks, and then I'd have all the blocks strung together as a second order bit stream that we'd parse again as an LZW bit stream, and then we would get back the raw pixels, which are really indices into the color tables. So there's a default global color table here, which has all the red, green, blue, 256 indices for each. So each decompressed LZW byte, or each decompressed byte from the LZW bitstream gives you an index from 0 to 255, and then you just look up the red, green, and blue components from the global color table, unless the image you're in has a local color table. And that's described in this image descriptor. If this flag is a 1, then you would look it up in the local color table instead. So that would be the second pass. The second pass would say, with all these blocks here, all this raw data, decompress it, and then index into the color tables, and then you get pixels out. Then we'd have to take the pixels and we'd have to arrange it as 300 by 300 and draw it somewhere. You would love to see image file converted into hex code. That's the opposite direction, called encoding, and that's even harder. So this is a decoder. Decoders are easy because you just follow a recipe and figure out what every byte means. To encode, you start with the image, and then you decide, well, how am I going to break this up? Like GIF is probably easy because there's not many decisions, but some image formats have like alternatives. Like you could use different levels of compression, or even in GIF, like do you use a local color table or just use the global one, right? These are encoder decisions that are harder to make. They're not as straightforward. Decoders are really easy in comparison, because you just figure out what every byte means. You're done. The hardest part, I think, with the GIF is that once you get all that raw pixel data, is actually showing it on the screen. Which, if you're curious, what we're looking at there was this particular image here. You probably guessed it by the lol.gif, but there you go. That's what we're looking at. So yeah, today what I was working on is when you click somewhere in one of the panels, that it shows you where you are on the right. And what I'm doing specifically now is when I click a byte here and I go down to here, see how it's like, where are we? It didn't scroll down to there. I want to have it scroll to wherever it selected it. So you have to find where it is. Oh, there it is. So I'm doing like the automatic scroll to thing right now. So that's what this scroll to is for. So we're going to set it. Now, the weird thing with how eGUI works is that we don't actually know where on the screen that is until we actually draw it. So that's similar to what I do in the hex editor, right? Scroll to. Yeah, that while we're drawing, if we have a scroll to, then we're going to do a UI scroll to rect. And we do it, I think what we'll do is we'll do it when we actually get to the row. So way down in here, we're actually, here we are. Here we're visiting rows and stuff like that, right? Yes, visit visible rows. We'll do it, I think we'll do it right here. So we'll say if some selected or scroll to row equals that. I don't want to take it out though. We'll just as ref it. Then we'll say if scroll to, if row token equals scroll to. Then we do this stuff. So what's wrong with this? Oh, do you reference? I don't have an offset to point. Oh, I don't need an offset to point. We have the y coordinate, right? So the top is y. So I don't need this stuff. I don't need top or bottom. We just scroll to rect from, I guess, min max, min size. So the min is position 2. I don't know. It just doesn't really matter. 0.0 and y is y. And then the size, don't care, and y is row height. And I forget what that is. Alignment. Okay, I don't care about that. So I think when we do this, then we do self.scroll to equals none. Because we've scrolled to it. Oh, can't use self. Use this. And as mute? No. How do I do this? I guess I can just take it out and put it back. Else this dot scroll to what's the opposite of take? It's like put? Not put. I guess I'll just say equals sum. How come I can't take it out there? Mutable reference. Oh, it's immutable. Dang. Okay, I can't do that. Then I won't take it out. I'll just do as ref. And what we'll do is after we're done drawing, we'll just clear it. So after this whole show thing, I guess I can do it at the very end. Way down here. I guess it's inside of this, the last thing we do here. I guess trying to pick a spot. Yeah, it would be down here, right? Self.scroll to equals none. Okay, let's see if this works. Is this an open source? No. I can't do open source. Job rules. Because of job rule number 3. Does it save it to text file once you decode something? I have a mode where I can do that, so hold on, let me quit it and show you. I have this mode where it does one line per part. So there we go, header, logical screen, go all the way to the bottom and we get the trailer, and we get all of those things in between. And we get like a 50,000 line long file. That's the first thing I started with. I thought the GUI would be more interesting. Okay, it almost scrolled to it. All right, I have to add that. I have to widen the box some, right? So it would be y minus 2.0 times row height. And this is, that's y. Y is y plus 2.0 times row height. Let's make that 3. Or just 1. Rule number 2 looks complicated. It just means I don't talk about work. If I leave the job, I can publish it, right? You mean if I leave my job, I can publish it? Yeah, probably. They stipulate can't do any open source. Well, I have to get permission. Because the lawyers have to review it to make sure it's not a conflict of interest. Okay, we could almost scroll to it. Actually, we didn't scroll anywhere near it. How come that didn't work? That worked. How come that's not working? We're like several rows away from it. Oh, am I not taking the canvas offset into account? No, we are taking it into account. Let's go extreme. 5 times the row height. It's supposed to scroll to that. But that work is for data science. Can't talk about it. Okay, it's still not working. You know, it's scrolling in the wrong direction, I think. So how do I fix that? Oh, this is wrong, right? That should be double. It actually shouldn't use y at all here. It's a size, right? So this should be like 10 times the row height. There we go. See, now I piqued your interest. I'm sorry I can't tell you about it, though. Still bad. Why? Where's the selected row now? Way down there? What the heck? If it scrolls up, it can find it. But not when it scrolls down. What am I doing wrong here? I don't know what I'm doing right here. Oh, I see what you're saying anonymously. You're interested in what I'm working on here, not my job work, not work, but stream work. This could be used for reverse engineering. There's one of my moderators reverse engineers old game files, and he was saying that this would be really useful for that. You're building up your startup before graduation at some link. Okay, cool. I'm bummed that this isn't quite working. How am I going to fix this? So is this, am I misinterpreting this? No, it's min plus size. The size is 10 times the row height. The position is we take y, which should be like where the row is, because this basically is just adding, oh wait, I think I know what it is. It's before it got expanded, right? No, because it was already expanded. See, it should all be expanded now. The whole global color table should be expanded, so it should be able to find these things. Well, now it's finding them. Only if it scrolls up, though. If it scrolls down, it still can't find it. And the problem is it's just not scrolling far enough. Hey there, kitty. Why are you sitting over there, huh? Giving me licks? Hold on. Second camera. Give me licks. Aw, cute kitty. I don't know why she's sitting there. Turn on that camera again. You don't want to lick my finger again? You just want to look into the camera? Look over there. Nah, she's done playing with me. She just wants to give me the evil eye. Don't scratch her. Yeah, don't claw my face off, please. There she goes. Just gonna go behind. Oh no, don't go behind the green screen. Oh, nope, and nope. Bad kitty. She's like, I'm gonna really piss you off now. I'm gonna go behind your green screen. 2, 3, 4, 5. It's going like. Oh, I see what the problem is. It's going to where it thinks we want it to go to. Okay, then I can't do okay, lost my place. Here. I can't do -5. I have to do it's just y then. To row height. That didn't work at all. Well, it's right just off screen there. Yeah, this is not working at all. I made it worse. Okay, most of the time, I think I know what it is. The first time we go to it, it actually expands it, and so the coordinates are off. So I have to do the scroll to like, yeah, I have to delay it or something like that. I don't know. This one I think I need to sleep on. Whoops. Well, I wonder if I could just add a fixed amount to wherever it finds. Wouldn't that be just adding 5 times row height here? but leaving the size at 1 row. This seems like a hack to me. But you know what? I don't mind hacks. I think if it has to scroll up, it won't find it though. So yeah, the first time you click it, it has to expand it, and so we won't have scrolled to the right spot. See, now it's finding it. It's weird that it's always going that direction. What if I like move it down to there? Yeah, it's always scrolling up for some reason. Weird reason. I don't know. Yeah. Anyway. What did it just select there? Image data. Oh, right, because there's nothing better. Yeah. Okay. I think this is good enough for now. It's at least doing the expanding part, and it's putting it somewhere on the screen. Netscape 2.0. Okay, I think I'm gonna sleep on it. I'm going to back this up out of the virtual machine. What GUI library is? It's eGUI. I am writing an extension to eGUI. So the way you do it is you make eGUI dependency, and then you basically just write a structure that hold on, let me find the right thing. You have a method of your structure that takes an eGUI UI and draws itself. That since it's an immediate mode GUI, every time you draw it, every time you draw, you get a context to draw into. So and it's also doing the layout too. So we're allocating space on the screen, and then we're using its painter to draw rectangles and stuff like that. And on the back end, it gives us a bunch of geometry that we pass to. I'm using WGPU to draw that, which is it's basically a portable wrapper over OpenGL or Metal or what are the other popular ones? DirectX or see, it's too late. I can't remember my graphics libraries. Your favorite graphics library? WebGPU maybe? Yeah, this code is horrible. I need to refactor this. Not tonight though. What am I going to leave you guys with? Wait, we're still printing stuff? Wait, what is that? What the heck? What is this? Do I have a debug somewhere still? Nope. Do I have a print line? There, but this isn't actually printing anything, is it? Okay, then yeah, I don't know what it was, what all this stuff was. I'm guessing it's just my shell acting up. Let's just close everything. Clean shell. All right, I have no idea when I'm gonna do a next stream. I just know it's not gonna be for another day and a half because I can't stream tomorrow. So I will be back on Friday probably, and by then I'll have thought of what I want to do next. I think it's time to go watch an artist in Australia. We're gonna go do that. And I hope, yeah, Vulcan. That was the other one I couldn't think of. Vulcan. You got it. So I will see you next time, probably on Friday. All right. Thanks for watching. Bye-bye.